Good evening, good afternoon, mathematicians, I should say. We're going to do a short office hour today just to do one. I had several tutoring sessions in the morning, and then I taught my first class of the semester. I meant to, I don't know, I guess I just forgot. I thought about recording a bit of myself, and I was maybe going to make like a YouTube short of like, oh, day in the life of a university math teacher. Hello, Jack Brolin. Good afternoon. But I messed up. I guess I could still do it literally any other day of the year and be like, yeah. Anywho, I don't have any plan for today other than I want to be done by 4. As you can see, it's not a lean stream. I don't know. We'll just yap about random stuff, you know. Maybe go look at arXiv. Maybe go look at Reddit. We haven't seen stuff for a while. Yeah, I don't know. I was looking at Reddit earlier, Mathra. I didn't see anything in particular I really wanted to talk about. Yeah. Good afternoon, Raymond. Good afternoon. I don't think I've seen any new Langlands papers. There's always something interesting when I look at group theory, though. Almost always. Or finite groups. What does that say about me? Probably says a lot. Local information of ADC quadratic lattices over algebraic number fields. I'm intrigued. Isospectral Cayley graphs. I'm intrigued. Primeness property. Ooh, affine Hecke and Schur algebras of type A without a square root of Q. Interesting. Have I used gap at all? No, not directly. I think you commented this question on another video, right? No, I've not used gap directly. Other than, I mean, I think Sage, I don't know if Sage is tapped into gap, or you can use the gap classification of groups to specify what group you're talking about, right? You can be like gap group 3212 or something. But no, I've only ever used Sage. I've never needed to do more serious group theory, and the group theory I've done in Sage has mostly been for fun. So yeah, let's take a look. Let's take a look at this. In this paper, counting formulas, density sets for representations of ADC lattices. I don't know what these even are. Motivated by Clark's concept of ADC quadratic forms. Non-Archimedean fields. Okay. Hello. And studied in non-Archimedean and algebraic number fields in 17. Okay. Q is called ADC if it represents every positive integer for which Q represents A over Q. What? Huh? Q is called ADC if it represents every positive integer I see. I see. So it means that it represents it over Z if it represents it over Q. I see. Okay. Originally comes from this result if the quadratic form with an integral gram matrix satisfies the Euclidean property, meaning that for all qx and q to the m there exists a y such that this, then it is ADC. Okie dokie. In this paper, we study the problem of ADCs over non-Archimedean fields, baby. Oh, and number of fields. Well, that's so good. That have not been covered by previous work. Nice. Characterize ADC lattices over arbitrary non-Archimedean local fields, especially in the unary, binary, and ternary cases. Bong? There's a bong theory? Hell yeah. Hell yeah. Nice. Adopting Bailey's bongs theory. Hell yeah. What a... This isn't algebraic number theory based as hell. We got bongs. Maybe I'll get demonetized for saying the word bong out loud so many times. But, hey, it's math. Dang, I'm tired. I think I should have eaten more earlier, but I was in a rush to get to school, to campus, and to teach. It's always more fun reading the introduction of a paper than reading the actual work. That's not true. That's a lie. That's a lie. I just don't feel like I have the bandwidth for any of this right now. What's the paper? It is called Local Information of ADC Quadratic Lattices over Algebraic Number Fields. But I'm going to go take a look at this thing. Isospectral Cayley graphs with even and odd spectrum. For group G and these subsets, we introduce the mirror die Cayley graph and the mirror die Cayley sum graph. Okay, then they compute the spectra of these graphs in terms of the corresponding Cayley graphs. Okay. This odd spectrum, an interesting phenomenon, seems to be new. We then study isospectrality between different pairs of these things. Okay. Finally, using unitary Cayley graphs. I don't even know what that means. Is that somehow it's the unit group of a ring over a finite commutative ring? Okay, yeah. Which is known to be integral. Interesting. I've never heard of such a thing. Wait, how is that different? How's that different? Oh, I see. The vertices are going to be the elements of the ring, and then you have an edge if they differ by a unit. Interesting. I mean, that'll be... disconnected in general? No, I'm trying to think. Maybe. Will it? Well, I'm trying to think. If we look at Z mod 6, if we look at Z mod 6, there's a guy that used 4 complex vectors as a wave. Huh? That doesn't make any sense. And turn them into quaternion vectors with the R4 sphere? I don't know what you mean. Oh, hello, Professor Mazoit. Actually, I don't know how to say your name. Mazwa? Mazwa, that's probably correct. Sorry. Sorry if I'm saying that incorrectly. Yeah. Actually, I wonder how good Google does at how to pronounce. Let's see what no, that's not quite right. Mazit. Mazu? Why professor? Because they're a professor. So I try to prefix people with the term professor if they are. I do, I should have, I do regret in my video, even though I was criticizing Professor Wildberger, I didn't call him Professor Wildberger in each instance. Yeah, but Thomas, your message doesn't really make a ton of sense. Oh, are you Dr. Matson? Perhaps I should call you Dr. Matson. A quaternionic potential conception with applying to 3D potential fields? Is Machizuki a misunderstood genius? That's not even the kind of question I feel like saying yes or no to, because Machizuki is, or at least was, a well-respected researcher in his field, and definitely very known for being talented. That's what I can say about that. Or if you're asking specifically, is IUTT correct? I mean, I'm not in any position to judge, but then again, how like a lot of people smarter than me have said no. So, yeah, Quaternionic. Science and Education Publishing. By analogy with complex analysis, any quaternionic holomorphic form. I was looking at someone's research profile while looking for, looking at postdocs, and I think they did say something about quaternionic analysis, but I don't know anything about that. I know obviously there's a lot of difficulties because things aren't commutative, so you have to be very careful, but that's all I know. What's my take on undergrad classes? They're all terrible, except for the one that I'm teaching this semester. It's the greatest course that anyone's ever taught, ever. But then otherwise skip all your other undergrad courses. I think I will maybe do like a transcript reveal / tier list of every course I ever took at some point. But no, I have a lot of videos to make before then that I promised I'd put out. I don't know what a quaternionic potential is, but you just finished understanding the inclusion-exclusion principle. Nice. Does that mean you're stupid? I mean, literally every person who was born ever was born not knowing inclusion, exclusion. And then at some point they learned inclusion, exclusion. So I don't think that alone can say if you're stupid or not. Solid advice, never take undergrad courses, yeah. You don't think that's the one? Check the author. It was the second one in the search. It's the correct author. Oh, maybe I got the title wrong. No, I got the title right. Yeah, it's the title you gave me, a quaternionic potential conception with applying to 3D fields. So undergrad is unfixable? I mean, I'm just joking around. I don't know. I wouldn't say it's unfixable. It's unfixable because it isn't broken. I don't know. The performed transfer of the complex potential conception to the quaternionic area. Okay. A 3D model of a potential field. Okay. The theory of complex potential plays an important role in complex analysis when describing the two-dimensional stationary vector fields. Yeah, I'm already out of my element here. Complex potential. What is complex potential vector fields? You're reading Apostle Calculus right now. Nice. Based. Complex potential vector fields describe 2D. What does that mean? So what is a potential function? Okay, is gradient gives the velocity in conservative vector fields. Okay. If I was given $1 million, would you still study math for fun? Absolutely. Are you kidding me? I would still be doing this YouTube channel. I would be doing nothing but math, actually. I'd be sitting on a beach all day doing math. That's how I'd be spending my life if I had $1 million. Do I think it's difficult for students to remember the inclusion exclusion? It came when considering the number of surjections. Do I think it's difficult? I don't think it's difficult for me. Do I think it's difficult for most students? I mean, I don't know. It shouldn't be. Do I smoke? Not cigarettes. I don't smoke cigarettes. I'll say that. Can I yap a bit about why tensor product of projective modules aren't necessarily projective over a non-commutative ring? If I don't do enough K-theory, I lose my name. I don't do enough K-theory. That's interesting. I don't know why that's true. Right. I guess what do we need? We need to come up with a counterexample. Yes, strange loop. Well, I don't agree. Prove it, strange loop. Prove it. Can I derive the Black-Scholes equation? I think you've asked me this before, and the answer is still no. I don't know how to derive the Black-Scholes equation. And I don't think I will anytime soon. Maybe we can learn it together. I did teach today. I did teach. In fact, these are my notes here from discrete math. Yeah. What math questions can't AI answer? Ones that humans haven't answered yet. That's not entirely true. Maybe this new Erdős problem is solved. So you're reading field theory for electromagnetism afterwards, and you want to see the geometric picture. After Apostle? Okay, tensor product projective modules. Yeah, I don't know. I don't know the reason. I mean, um, right. So we need to come up with a pair of modules whose tensor product, which are projective, whose tensor product is not projective. And we need to work over a non-commutative ring. So I don't know what's the easiest ring to work over. We could work over 2 by 2 real matrices, maybe. That's a non-commutative ring. And okay, so we can't just get away with free modules, right? Because definitely if we tensored up some free modules, it would be free, right? That should be true. You're that guy that wanted to go to math applied to economics, but now you decided to go to business analytics. What do I think you should study related to maths? ALR had algebra. I don't know what ALR is. Calculus and statistics. I don't know. I don't know, to be honest. I don't know much about business analytics. So if you're asking about if you're asking about business analytics, yeah, I can't really help you. You'll have to look at the ALRs already. Okay, yeah. But yeah, I don't know. You'd have to look at the syllabus, the courses for business analytics. I don't know anything about the math that's useful there. C is the best ring to work over. Yes, but it's commutative. We need non-commutative. Or you mean I should put it? I should do matrices over C. Maybe life is easier then. You attempted to explain it in your own words. The intuition behind the formula. You'd love to share it with people. Well, then you should share it with people, I suppose. No, on this physics book on EM and GR. Do I know Shlomo Sternberg? I do not. I do not. Well, I'm glad that you are enjoying the content anyways. Can I check out your project on it and let you know what I think? You tried to explain it with simple words, what the equation is for. Sure. You can send me an email. I'm not gonna make you any promises about when I'll get around to actually looking at it. But you can send it to me and I can take a quick look and actually I'm the right person to ask for that because I'm a mathematician, but I don't work in that field. So if it makes sense to me, then you probably did a good job. Yes, you can't share the link here. YouTube won't let you, but you can send me an email. You can send me an email and I'll take a look at it. Let's see. Examples of non-free projective modules over a non-commutative ring. I should know these things off by heart, but yeah, matrix rings, of course. Okay. So, right. This will be an example. Allegedly, this is an example of a projective module that is not free. Interesting. So interesting. So then what about so then what if we took, I mean, is this an example? We could take C2, tensor C2 over this. I don't know if this even works. Like maybe this ends up being projective still. Yeah, I feel like there's something with the... Yeah, it's interesting. It's interesting. So, like... Right, what's it? Shudo? What wouldn't you do? Oh, you wouldn't explain how to explain tensor products to the average person in the street? Yes, I agree with Shudo's answer. I wouldn't. I just wouldn't. Okay, so can we realize this? Can we prove that this is not projective? Okay, what's the best way? I'm trying to... It's been so long since I've proved that something wasn't a projective module. How could we do it? I mean, could try and cook up an explicit exact sequence that it fails. I guess one could try to cook up. I mean, one could always go. Maybe this may not be the best way, but one should compute. Could compute X. So we could try and come up with a resolution. I'm not even sure that this is a valid example, though, but okay. Although I do wonder... Yeah, how do projective resolutions work with respect to tensor products? I don't think I can just take if I have a tensor product of two things, I can't necessarily resolve the tensor product with a tensor product of resolutions, though, can I? Maybe. Yeah, I don't know. This is it's a good question, but I'm so out of practice on thinking about proving things are projective or not. He was a geometer, and he published a book on differential geometry, lectures on differential geometry. You want to finish apostle multivariable calculus first. Well, that's probably a good idea. I'm not sure, Thomas, what your question is about it depending on the polynomial. Okay. What do we do? Right. What would a resolution... I mean, could we think about what a resolution of C2 would look like in this case? Like, I wonder if we tried taking a free resolution, even. What could that be like? Like, somehow if we projected, maybe if we show that C2 isn't flat, and then work our way up from there. Maybe. Right, because if C2 wasn't, if we could cook up an example where flatness failed... Well, no. How would that, but how does that help us with the projective example? How does that help us with proving it's not projective? C2 has to be non-flat. Well, we do have, because, I mean, we're trying to prove that this, I wonder... We're trying to prove that this fails to be exact. Can we use some adjunction pushing? But I think the tensor hom is on the wrong side, right? It's also embarrassing I even have to look this up. No. Oh, okay. Okay. Hang on a second. Hang on a second. Maybe we could use tensor homojunction here. Right. So y, x, right? Because it's hom y tensor x into z is hom y hom xz, right? Aha. Adjunctions making our life easier. You still have to look up reverse triangle inequality. Yeah. Fair. Still, I feel like, an algebraist. Someone that works with the things that I do. I feel like this should be tattooed on your brain. Okay. But this is interesting, right? Because wait a second. I guess we also have to be careful. We also have to be careful about the fact. We have to be careful about the fact this is the non-commutative case, actually. So actually, how is this even an example? Because C2, hello, head empty set. Because C2 needs to be a left module. So, but I guess we could be taking it as like you take the transpose and you multiply. Wait, does this even work? Yeah. No, it doesn't even work. No, wait, it does. Wow, I'm so confused. No, it works. Right, and then transpose back. Okay. But we need to be specific here about the module actions that are happening. Wait a second. Oh yeah. So wait. Actually, this question is confusing because let's go back to the whole beginning of this question because so what does that even mean? Luna, wait, set theory Discord server Luna? True? Is this the case? Have I recalled most correctly? Yeah, the confusing thing here is that P and Q, so projective in what sense, right? Wait a second. One of these needs to be a bimodule, right? One of these needs to be a bimodule. Because otherwise this isn't even a module, right? So it needs to be what? So P is an what? R bimodule. Which is what? Projective on the, and then this could either be left or right, and then Q is a projective left R module. Because maybe the answer, I don't even know, but the answer to this question may depend on whether, like, if P is bi-projective versus just projective on one side. Yeah, I don't know. Okay. And what about Isn't the same thing that thesis you mentioned talked about? Um, uh, I don't think so. This seems to have nothing to do with what we're talking about now, to be honest. Hello, Professor Escardoso. I hope I said that correctly as well. Thanks for sending that email. I kind of feel bad because I realized I looked at it and then I saw the paper and then I was like, actually, a lot of the questions, are answered there. So, you didn't have to spend all that time writing. But thank you. It'll probably be a while before I have a good, careful look at some of these things again. But thanks for sending it. I do appreciate it. I do appreciate it. Yeah. Okay, where are we? Yeah, maybe that's the next thing we could all look at together. I don't know. Now I'm of two minds. Part of me kind of wants to look into quaternionic analysis and how to make that rigorous. And another part of me wants to dig deeper into this module theory question. Crystal-adic, are you even sure that this theorem is true? The statement, I don't know where the statement's from. Why tensor product of projectives aren't necessarily projective over non-commutative rings. Because I would say this depends on getting that right. But okay, let's but it seems a little weird because if we use this adjunction, and I guess I should be careful too, because for the non-commutative case, we have to think carefully about what this means. Because technically, I mean, the tensor product only gives you an abelian group, right? Like, if you're not tensoring bimodules, then isn't this technically just abelian group Hams? Yeah, I'm not sure. But then it would seem weird to me. It would seem weird to me that it wouldn't even be true. Like, this almost makes me think that taking the tensor product would be projective, because like, so if you go A, B, C, and then you Hammed into the tensor, right? And then you use the natural isomorphism via the adjunction. I mean, it looks like you're doing a double application of the Hom functor by projective things, right? So, oh God, I'm writing so big I'm out of room. So it kind of seems as though, this thing should be exact. But yeah, maybe there's something weird going on here with like commutativity and the adjunction and stuff. You figured that's why K naught isn't a ring for non-commutative rings as input? And Weibel's K theory has this as an exercise for commutative rings. I see. Well, how is It depends on how you define K naught, though, right? Because there's like, yeah, there's the indecomposable. Actually, there's something about this in a char. There's like the there's like the K ring for like the category of like, what am I trying to say here? There's one which is spanned by the indecomposables, and another one which is just spanned by the simples. If we go over to Grothendieck groups here. Right. So what I'm used to working with is the split Grothendieck group, where it's on the isomorphism classes, but then you also have this has to be a Krull-Schmidt category. I forget what that is. But then you can also form this ring. They end up being isomorphic, I guess. But maybe there's something weird going on there. I don't know. What do mathematicians mean when they say tools? I guess they sort of mean lemmas, or I guess they mean lemmas, right? In a sense, like a tool, you know. What's a good example? Like, yeah, I mean, in the same way that like a physical tool that helps you build the house, it's just something that sometimes they mean PhD students. Yeah, they mean that all the time. But it's like you use a hammer. A hammer can help you put nails in a board and take nails out of a board and things like this. So like induction, right? It can help you prove. It's one strategy to prove a theorem, right? So it's a tool, because once you understand it, you can just sort of apply it, and it will help you know help you prove something. Yeah. Uh, yeah. Well, I think part of the problem actually, crystallitic. Now that I mention it, I think part of the problem is just that. Uh, first off, in any case, the Grothendieck group, of like a category of modules, should be spanned by, I mean, isomorphism classes of modules, right? And so the question is, well, how do you define a product? And so, but the thing is, so let's say R, let's say like, I'll put MR to mean like left module specifically, right? So like the objects of this ring should be isomorphism classes of modules, right? So then, okay, you say, oh, I want to define a product on modules, right? And you think, oh, the tensor product, but the problem is, in order to take the tensor product of modules over a non-commutative ring, A needs to be left, and A needs to be a right module, and B needs to be a left module. But A's not even it. A's not necessarily a right module, right? So yeah, toy model is another term. It's sort of just like an easy example, right? Or good morning, Ken. Yeah, it's just another, like, it's like an easy example or an illustrative example. Um, yeah, yeah, that's meaning of toy model. Well, unfortunately, Ken, I know sometimes you have a habit of getting here just as I'm leaving, so I do apologize, but it's 4:06. I'd said I wanted to wrap it up at about 4, so I think that's where we're gonna end it for today. Um, Yeah, that's interesting. So I think Crystal Addict, maybe we were able to resolve your question, but hopefully, um, hopefully, uh, what am I saying? Tomorrow morning, I think we'll be back to normal time tomorrow morning, and we might do quaternionic analysis. You just got here. Can we ask questions? Yes, but I'm leaving. Normally you can ask whatever you want, but I'm leaving right away. But you know, tomorrow morning I'll probably be live streaming again, as I do most mornings. So, or you know what? You can almost you can always comment on the video afterwards. I won't promise I'll be able to answer your question or that I'll be motivated to take the time to answer, but you know, you can comment. Um, uh, uh, yeah. You didn't think about that being the problem. Oh well, thank you. I'm glad that you think I'm a great lecturer. Do I think I could be a dungeon master in algebraic topology D&D? I don't know. I don't know. Do I have the depth of knowledge? Uh, maybe. I don't know. Um, does sound fun. Does sound fun. About any topic, yeah. You could. Hey, in my live streams, you could ask me anything you want. There's no rules, but you know, if you say something absolutely terrible, then you're gone. You know you could ask me about like what's the best kazoo for um, a classical musical concert. I don't think I could. I don't think there's an answer. B, I'm not qualified to talk about it. But you know, you can ask me anything. Okay, I'm out of here for real though. So QED.